Okay, so this problem states that two blocks are in contact on a frictionless surface. So this is the frictionless surface and two blocks are in contact. A horizontal force is applied to the larger block. So M1 is the larger block which has mass of 2.3 kilograms and M2 has mass of 1.2 kilograms. So M1 is 2.3 and M1 is 1.2 kg. So the applied force is 3.2 newtons, that's given there. So we need to find the magnitude of force between the two blocks. So the force that block M2 experienced, the flow force between two block, that's what we need to find. So since they are in contact and the force is applied, the surface is frictionless, so they will have a common acceleration, that will be a. Let's say the acceleration is a. So F will be equal to m1 plus m2 equal times a. So a can be found by F over m1 plus m2. So this one is 3.2, this is 2.3 plus 1.2, so that's 3.2 divided by 3.5, so approximately 0.914 meter per second square. So that is the acceleration. Now we need to find, in the first part of the problem, is what is the force here, force between the two blocks. So that will be the force, if we call that force, I don't know, maybe m12, if we say, that will be m2 times a, because this will be here and that will be the force that this mass experiences. So that will be 1.2 times 0.914, and once that's done is approximately 1.1 Newton. Now in the second part of the problem it says that what will be the magnitude of the force between the two blocks if F is applied to the smaller block in the opposite direction. So in the original problem, F is in this direction and it is applied on the larger block, that is M1. But let's say F is applied on the smaller block. That means F is applied here and its magnitude is still the same, 3.2 Newton. So in that case, what will be the force force between the two blocks? So acceleration will again be the same because total mass is same. But force this time, the force between two blocks, whatever, I don't know if I again call it 1 2 or we can say 2 1, I don't know. Let's just leave it like that, the same force, but it will be in this direction now because this is also in this direction, and of course, so this time the force will be m1 times a basically, and m1 is 2.3 into 0.914. The acceleration will be the same because acceleration is calculated with using the sum of the masses. So m1 plus m2. So now the force between the blocks will be 2.3 times 0.914, approximately 2.1 Newton. So basically the the force between the two blocks is dependent on the mass of the right hand side. So basically on the direction of the force, whatever that force is, whatever that mass is experiencing, that will be the force basically, and that will be calculated using that mass. So for example, if the same problem had three blocks like this, then of course the total force would be sum of all three masses, so m1 m2 plus m3 and a. So m1 m2 m3, that would be the total, that would be the force here, and that we would use that to find the acceleration. Let's say once we don't know the acceleration, this one's acceleration is a, this one's a, this one's a, but the force between these two blocks would be sum of these two masses times the acceleration. The force between these two blocks would be sum, or will be just this mass times the acceleration. And of course the force here is actually sum of all three masses and acceleration. That's how we calculated the acceleration. But once we know the acceleration, we can find the force between these two blocks, let's say 1 and 2, 3. So between 1 and 2 would be sum of these two blocks on the right side, whatever blocks remaining, that two blocks mass times or divided the force divided by that two mass, the sum of that two mass would be the acceleration is known, so sum of that two mass times the acceleration would be the force. So here if the force is F12, let's say, that would be this acceleration and then m2 plus m3 times that acceleration. That's how it would be. And if we call this force to be F23, that would be m3 times A. Only that mass, because we are calculating force here in between these two blocks, that would be just this mass times the acceleration. So yeah.